Hello everyone, welcome to Imagine Science Film's Experimenta series. This week, in lieu of the World Cup, we're going to be discussing aerosols and air pollution and kind of the air in the environment. Specifically, our interest was in Brazil and how these games are taking place so close to the Amazon, and there's all of these urban environments that are packed with tourists and people during the World Cup that, there are some pollution problems and how this might affect the players' ability to process air and if their game is different in one city to the next, and kind of this whole system that's occurring in the air. So today we're going to be talking with Meinrat Andreae, a German biogeochemist, and he works at the Max Planck Institute for Chemistry, and his research studies the exchange of trace gases between vegetation systems in the atmosphere, the effects of vegetation on ecology and the atmosphere, as well as the effects of aerosols in global climate. So today he's going to be kind of commenting on this kind of overall system and specifically commenting on some of the research that's taking place in the Amazon right now. So do you want to, I guess, tell us a little bit about how you got interested in this field of research?
Yeah, well, I started out actually studying just plain old chemistry, and then at some point I decided that, spending my life in the lab wasn't going to be it for me. And so I branched out or shifted over to a field called geochemistry, which basically is looking at the chemistry of the Earth system. Originally, I started with rocks and then got a degree in oceanography or marine chemistry, ocean chemistry, and then sort of worked my way upward into the atmosphere. So now what I'm doing is research on how the surface of the Earth covered with living organisms sort of interacts with the atmosphere, how trace gases are exchanged, what the atmosphere does to the biosphere through living organisms, and conversely, what living organisms do to the atmosphere.
No, that's fascinating. I mean, as you can see, I stumbled on words there when I was trying to say biogeochemistry because it's such an interdisciplinary field of work. I mean, you're really studying the system at whole. Do you want to comment a little bit about how your research focuses on human ability to be able to deal with kind of the changes in our environment, as well as effects of vegetation systems?
Well, of course, the big way that everybody talks about these days is how human activities affect climate, how obviously what people put in the atmosphere, mostly carbon dioxide, but also some other things, such as methane or black carbon soot, are able to affect climate and lead to warming effects in the atmosphere. And so since carbon dioxide, of course, is not just emitted by the smokestacks and by car exhausts, but it's also continuously exchanged with the biosphere. Plants are taking up CO2 anytime plants are burned, for instance, in deforestation. The CO2 goes into the atmosphere. That's how very closely connected the biota are with the atmosphere, and through that with the climate system. And that's sort of really the overall environment in which we do our work, which, as always, when you do science, that becomes, of course, quite specialized again.
Right. So what would you say is the, I guess, strongest effect that humans can have on their environment? Whether it's detrimental or not, is there something specific that your research focuses most in?
Well, obviously, again, it's the huge emissions of CO2 probably are the single biggest effect that people have on the environment. Mm-hmm. But then there's also the massive change in the character of the surface of the Earth. Just imagine yourself again on one of the flights that you're taking, and when you look down at the ground, then there is hardly a piece of land that looks like it may have looked like a few hundred or 1,000 years ago. So people really have changed the surface of the land very deeply and extensively, and that also changes everything. That changes the kinds and amount of trace gases that go into the atmosphere. Before There may have been a pine forest, for instance, which puts out things like terpenes, the sort of things we smell in the forest. Now there may be, say, a cornfield or something like that, which has completely different effects on both the amount of water, for instance, that's being recycled, the amount of heat that's being trapped at the surface, and the kinds and amounts of gases that are going in and out of the atmosphere.
So how long do these different systems really take effect, like, and we can really see them in the atmosphere, and they have effect on the ecosystem?
Well, you name the time scale, just about all. There's arguments that actually human activities, even as far back as 500, 600, 700 years ago, when people started to really change the Earth in larger scale, sort of together with the Spanish conquest, there's arguments that even at those times there are noticeable effects on atmospheric composition. Of course, they have increased very sharply in the middle of the 19th century when people started to go into industrial use of coal, especially at that time. And so the industrialization was the biggest jump. And then as humanity has increased in numbers exponentially over the last 100 years or so, of course, these effects have sort of gone up dramatically and sharply over the last few decades. So there is this sort of, well, you could call it a secular time scale. And then there's also, of course, a very short time scale that deals with all the immediate pollution emissions that are happening around us sort of on a very nearby and short time scale.
Yeah, there was definitely some concern in Rio regarding the World Cup and the amount of pollution that it would bring with so many flights coming in and out and the increase in traffic. What effect do you think that had on the Amazon, if any?
Well, of course, on the Amazon, not so much, I would say, because the Amazon is actually quite far away from Rio, Sao Paulo, and so on, the urban areas. I would also suspect that really, well, let's put it this way. I've been in Sao Paulo, which is sort of the largest and most industrialized city of Brazil many times. And I've experienced the pollution that's just simply there because there is, I don't know what the number of people is, but it's over 10 million people who live in this metropolitan area. And so there's just a huge amount of pollution there every day of the year. And so I would sort of doubt that actually the increase that's due to the World Cup would have made that problem seriously worse. It's just a very highly polluted environment, and well, you know, not so different from Los Angeles and other large-scale metropolitan areas. Just wherever a lot of people are together in a relatively narrow region and drive their cars, have industrial activities, and so on, just have a very serious air pollution burden.
Yeah. Do you think that in order to move forward and prevent these, rapid changes to the environment, it would be best suited to approach it from kind of a policy standpoint, or more of a personal approach on the individual scale of kind of individuals taking that initiative to not drive so much or travel so frequently?
Well, I think the two probably have to come together, but I think there's a serious need for actually policy interventions. A good example is in Brazil, in the specific case of the Amazon where we're working, is deforestation, which destroys rainforests and also creates huge amounts of pollution because actually the deforestation happens mostly through burning of the forest. So it turns out that if you go into especially the southern part of the Amazon basin, every year in August, September, October, the pollution is just about the worst you can find anywhere in the world because the sky is so thick with the smog from burning, just the smoke and the soot that gets cooked by solar photochemical activity out of all these emissions from biomass burning. So that's actually a serious health problem for the people who live there. It's a serious problem for even plant growth. So that's a real issue, okay? And Brazil actually has, over the last few years, last decade or so, made huge amounts of progress in mitigating and reducing deforestation and thus burning. So air quality has actually improved significantly in the Amazon region over the last decade or so because of policy interventions. Basically, they've instituted things like denying credits to people who conduct illegal deforestation. So if you're like a rancher or a land developer and you're caught illegally deforesting, then your business is going to get into a serious problem because you need, of course, your credit and so on for farming. So a number of policy interventions. Or Brazil has introduced very efficient monitoring of deforestation and burning by satellite detection. So I think that was very important. Of course, it also is important what the decision that people make, both on the personal scale and at the ballot box. So if you put solar panels on your house and insulate your walls, obviously you're making a significant contribution. But probably that sort of bottom-up approach ultimately wouldn't be enough to solve the problem.
Right. So in terms of the positive deforestation that is happening, what you mentioned was that sometimes the amount of biomass that's burned is actually also detrimental to some ecosystems. What is kind of the method of finding a balance there in terms of preserving the forest as well as the other surrounding ecosystems, as well as public health and the communities living right there? I mean, is there some kind of balance that's been established?
Well, yeah, I mean, right now there is a sort of a transition to actually getting more bang for the buck in a way by using the land that has already been cleared more efficiently and actually reconstituting some land that has been deforested and then deteriorated and so taken out of use again. So for instance, the typical use of land that's deforested was for cattle ranching, and cattle ranching has a very low yield per hectare or something like that in terms of just how many dollars you can get out of running a cattle ranch per hectare of land that you're using. So people have transitioned from cattle ranching to soy farming, which has just produced a lot more income per hectare of land. And so there's a lot that can be done by using land that's already deforested or by using land that's has been deforested and then had some partial regrowth because it's basically abandoned. And so there are economic models in regions of Brazil that are actively conducting land use change to make it economically viable for the population there. And then there are other regions like the state of Amazonas, which actually happens to be the area where we do most of our work. And the state of Amazonas basically says, okay, well, let's not do very much to the forest. Let's just concentrate our economic activity in some industrialized urban areas with a high amount of economic gain produced per amount of investment and per amount of energy use. So they have a big high-tech industry which has a large amount of value added in the region of Manaus, and then let's basically leave most of the rest of the state more or less untouched and just very thinly populated by a population that lives sort of fairly simple lifestyles, traditional simple lifestyles. So that's a completely different economic model.
Yeah, that's so interesting. So in terms of your field work that happens in the Amazon, do you want to tell us a little bit about specifically what your research focuses on when you're down there?
Well, actually, what brought us originally there, which was originally being 1985, actually, was a NASA mission to look at what the first space shuttle pollution sensor had seen in this area, which was just a huge blob of carbon monoxide. And the idea at the time was that this carbon monoxide was a product of photochemical oxidation from the hydrocarbons that came out of the forest, out of the trees. And well, the older ones among us remember Ronald Reagan and his idea that the most polluting things are trees because of the putting out all these hydrocarbons. And in a way, he was right in the sense that trees indeed put out lots of hydrocarbons, and so they have a big influence on the atmosphere. And the other stories why he wasn't right, but anyway, the idea was that there was this carbon monoxide that's being produced in the atmosphere. It turned out that the carbon monoxide was indeed there, the trees were indeed there putting out hydrocarbons, but the reason why there was this big blob of carbon monoxide was from all the fires of deforestation. And the burning really released the carbon monoxide. And so since then we've sort of gone back there, well, for one reason to look at these atmospheric effects of biomass burning, but also kind of for the original reason, because the Amazon is one of the last systems of the world that's relatively untouched, and where sort of some of the time you can get an atmosphere that's relatively unpolluted. And so I have to be cautious because actually pollution gets transported over long distances. So there's not really any place in the world right now that you would be able to call totally unpolluted. But in the Amazon, we have sort of a chance to look for an atmosphere that may resemble to a certain extent the natural atmosphere. And that's sort of our mission really is not so much to look at pollution. Our mission is to try and see what may have the atmosphere been like before humans polluted it.
Wow, so the Amazon is almost acting as the source for the control for, you know, a whole plethora of different research kind of sects on the environment. That's really interesting. No, continue.
Obviously, if you want to understand the human impact, you have to have some control there. You have to say, okay, well, what would the system be like without the human impact? And so for the atmosphere, that's actually a fairly difficult task because the pollution is so pervasive and the atmosphere moves around so fast that original state really is difficult to reconstruct.
So are there any other, I guess, comparable forests and environments that you kind of have looked into to kind of define this control? Or is the Amazon really the standalone, kind of the last pure environment left?
Well, we actually have a similar, somewhat more simple activity going on in the middle of Siberia. The Amazon, of course, is a wet tropical forest, okay, so it's one very specific type of ecosystem, one that covers large parts of the Earth, but of course is not representative of all natural environment. And so our other environment that we're looking at is the boreal forest, the forest in mid and higher latitudes, and for that we're going to the middle of Siberia.
Wow. So really just traveling all over the world.
Yeah. And so what we've done in some 10 years ago in Siberia is actually set up a tower which is 300 meters, about 1,000 feet high, sort of like one of these big radio transmission towers. And we're using that to sample the atmosphere sort of a little bit above the surface, so we get to a more representative point of measurement than by being directly over the forest.
Wow. And is there a certain time of year that's best for you to take these samples?
We're measuring continuously 24/7, 365.
Wow.
Yeah. So that's basically what we used to be doing in the Amazon is just to go on there on campaign type expeditions, but now also we're in the middle of constructing one of these 300-meter towers in the Amazon. So it's actually supposed to be 326-meter high, which our Brazilian colleagues insisted on because they wanted to be higher than the Eiffel Tower.
Wow.
So, just,
trying to set a record. Well, I guess, are there any last comments that you have kind of regarding the atmosphere in Brazil and possibly how that could have affected the players' game from one stadium to the next? Because there's really stadiums spread not just in Rio, but in the surrounding areas. And some were in much more polluted environments, and some were, closer to the suburbs and kind of out of that downtown area. Do you think that had any effect on the game, or?
Well, in terms of air quality, I think most of them were relatively lucky because they played in relatively not so intensively polluted areas. Places like, Fortaleza, for instance, wouldn't be very, very strongly polluted. And Manaus also, especially this time of the year, has fairly clean air. And they were lucky in the sense that they played this time of year, because, of course, the big pollution that's related to the fires, which reaches into a lot of areas, happens in September. So, so those who didn't play, like in the really more polluted places like Sao Paulo and Rio, where there's enclosed air basins, were probably not too much impacted by air pollution. Probably the high temperatures, humidity, was a lot more stressful to them.
Yeah.
I think they held up fairly well, and I can't complain how the German team held up. So.
That's true.
Certainly, from that point of view, things were fairly.
It went well. Well, congratulations on your team. And thank you so much for taking the time to speak with us today. I'm sure our followers are fascinated by these different topics and really exploring the science and technology on the World Cup and really understanding how science and technology can be applied to so many different fields. So thank you so much, and I just want to remind our followers that it takes quite a bit to keep us running. So if you have any, will or would like to make a donation, just $10, it would be great and very helpful and will keep us going. And you can find the link to our CrowdRise on our event page. And again, thank you so much for your time, and hopefully we'll get to do an event with you in the near future.
Thank you. It was a pleasure.
All right. Have a great day.
Bye-bye.
Okay. Bye.